Hey guys! So, now that we've completed the first unit of the IB Chemistry syllabus, which is on quantitative chemistry, just sort of make sure you just go back and review that every now and then, okay? But now we're going to move on to the second unit, which is on atomic structure. So for this part, I just want you to pay very special attention because atomic structure is mostly a theoretical concept, okay? It's not that easy to understand as compared to some of the other topics that we'll be covering, so I just want you to make sure you pay special attention as I explain through these, okay? So you probably recognize this diagram here, probably instantly. So yes, this is a electron configuration diagram, specifically for aluminium, okay? So if you recall, let's do a little recap from IGCSE. So you remembered how electron configurations diagrams work. So basically the first shell can hold 2 electrons, second shell can hold 8, and the third can hold, I think it was 18, okay? So it's 2, 8, 18, and so forth, but in this case, aluminium, so the outer shell only has 3, okay? Because if we add them all up, it's equal to 13. If we just look at the periodic table, that kind of thing. And the electrons sort of orbit around the electron shells in this kind of fashion that we've drawn. So I hate to break it to you at this point, but this method of electron configuration is wrong, and it's highly inaccurate. Which also means that your science teachers have been lying to you for the past 5 years. Sorry, science teachers. This diagram here is wrong for a pretty good reason. Because, actually, I actually got a couple of pictures I want to show you today. So, this picture here, this is what we call an electron density diagram. So, it basically maps out all the possible locations of an electron within the domain of an atom. Okay? So as you can clearly see, the electrons are sort of randomly distributed across the entire page, but as you can see, most of the electrons are concentrated into a spherical shape here, with a few outliers around the sides, okay? So you probably would have guessed it by now if you just look at this, if you just compare that to this. So the spherical shape is basically the domain of the atom, okay? Now, one of the first things we can deduce from this diagram is the idea that the electrons don't actually orbit the electron shells. Why is that? Because if you think about it, if electrons actually have a fixed orbit around a shell, then you obviously see a clean cut of where the electrons would be, like a clean circle here, and a clean circle there, and a clean circle maybe on the outside, like this. Okay, so there wouldn't be any electrons between those electron shells. There wouldn't be any on the outside. Okay, so obviously, clearly, we can see that's wrong because the electrons are basically everywhere around the domain of the atom. So clearly the idea of having electrons orbiting the electron shells is wrong, okay? In this case, we can sort of deduce that electrons don't actually have a fixed path of orbit. They just kind of move around randomly within their electron shell at this point as you think about it, okay? So, and thus explaining the randomness of electrons across the electron density diagram. Okay, so that's the first thing. Now, the second thing I want to point out is that you might probably notice by now that some of the electrons are red in color, some of the electrons are black in color, okay? Now, the reason for this is because the reason for this is basically just for display purposes, because I've actually extrapolated the electron density diagram into 2 different diagrams, separated the blacks to the reds. Okay, actually, I think I should turn that around. Yeah, that's more like it. Okay, so while this black diagram would reflect what I've said in this diagram over here, okay, this red diagram here clearly does not. As you can see, because the black diagram is a sort of spherical shape, while the red diagram here is not. It's more of a dumbbell shape, as I've been taught to say it. Okay, so you might call this a figure 8, you might call this infinity, but I was basically taught saying that it was a dumbbell shape. Okay, but anyway. Further analysis of the nature of these electrons, like the amount of energy they hold, basically shows that some of these electrons are within the same electron shell as some of the electrons on the outside here. Oh, one more thing about electron shells. So electron shells is an IGCSE term. Okay, it's not really IB terminology here. So instead of calling it electron shells, okay, this part I want you to write it down. Instead of calling it electron shells, we now call it energy levels, okay? So as you can see, I've actually drawn a series of energy levels up here. So it's n equals 1, 2, 3, 4, and then all the way to infinity. At infinity, the electron basically leaves the atom, okay? So that's one way you can put it. Anyway, so as these electrons, they occupy the same energy level as some of the electrons on here, okay? then clearly we can see that electrons don't occupy the same space within one energy level, and therefore this disproves the idea that electrons are within the same exact energy level. Okay, because same exact electron shell in this case. Thus disproving the idea of having a shell. Okay, because the electrons don't actually belong in the same shell. So in the sense that the second shell should probably be split into two different ones, one to house the electrons here and one to house the electrons in this section here. And a quick thing I just want to mention about these, about the splitting of these electron shells is because another way you can think of the electron density diagram is basically areas where there's the highest probability of finding an electron. If you just take an atom out of a box right now and just have a look at it, well, imagine if you're really small, that is. So these areas where the highest probability of finding an electron are what we call orbitals. Okay, so let me just write that down. Let's use this pen today. That's basically what we call orbitals. So make sure you copy down this definition. Now, they won't ask you this definition in the exam, but it's better if you actually know it anyway. So, alright? So that's basically orbitals. Now, for this part, this is a bit too physics for you to understand at this point, okay? But the idea of actually splitting these energy levels into fitting different orbitals, as we can see here, because further analysis actually shows that this actually works. Because reality, let's say we have to focus on the energy level of n equals 2, okay? So for n equals 2, it's actually split into two different levels. So, firstly, we have one level here and one level here. Notice, and actually notice the effect that one is higher than the other because one has a higher energy level and the other has a relatively lower energy level. And note they're in the same overall energy level, but they're just occupying different space, and thus they have different energy levels. Okay, so here we have the orbital n equals 2p and the orbital n equals 2s. Okay, so So yes, and you might be wondering why I just called them S and P, not A and B, okay? Because that's basically the way it's named, okay? So, this part, unfortunately, there isn't really an explanation for it. You just need to memorize this part, okay? So, basically, there are different orbitals within an atom, okay? So, there's S, P, D, F, and it basically continues like all the way. After F, it's basically followed by alphabetical order, skipping these along the way. So, it's going to be like F, G, H, I, J, K, L, M, N, O, P, Q, R, and then skip S, T, U, V, blah, 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 blah. Okay? Basically, that's how it works. Okay? But in the IB syllabus, the most that you need to know is basically these. These are the essentials that you need to know. D is, there's a part of it that you need to know. F is sort of, you need to have knowledge of it, but you don't actually need to use it in the exam. So, basically across the atomic structure unit, we're going to be focusing on these three orbitals mainly. All right. So, I know this part is actually quite a lot to take in, especially with the electron density diagrams that I've covered here. So, in the next video, we're going to be covering those in more detail because this is basically just a brief introduction, just to get the gears in your heads turning. Okay. I'll see you guys next time.